Alright, so in this video, we're going to continue dividing by decimals in this case. Okay, and we're going to talk about some slightly more complex ones where the number that you're dividing by, which is the second number, okay, the number you're dividing by, if that is not a whole number, it kind of doesn't make sense, really. Because really, if I took as an example something like 6 divided by 3, here's what this means. It means that I'm saying, here are my 6 things, okay, and I'm going to divide them into 3 equal sections, right? So here's my 3 equal sections, and the answer is really how many things are in each of these 3 equal sections, and there's your 2, right? Each of these has 2 in them. That's why 6 divided by 3 is 2. So when I get down to something like this, I'm saying I have 5.4 things, and I would like to divide them into 0.2 groups. And it's kind of like, well, that doesn't make a whole lot of sense. Like, how do I take a group of something and split it up into equal sections that are fractions, right? That kind of like starts to blow your mind there a little bit. And so what we're going to do is we're going to always try to divide by a whole number. So when we're asking this question, how many sections am I dividing this into, it's going to make sense, right? So here's the idea. If I go to this problem, 5.4 divided by 0.2, I never want to see this. That's bad, right? This one, never want to see that. That's bad. So here's what we're going to do instead. I'm allowed to move this decimal point over once and turn this into a 2. But if I do that, the other number has to be moved over as well. So I move this over one time, I'm going to move this over one time, and I'm going to do that. Okay? And if you notice, 54 divided by 2, well, that's a way easier problem than dealing with all these decimals. So let's do 2 into 54. So 2 goes into 54. Okay, well, 2 goes into 5 twice, right, because we can get as close as 4. Okay? And then I'm going to say 1, bring down my 4. 2 goes into 14 7 times. 7 times 2 is 14. Okay? No remainder. That was beautiful. And so here's what that means. If I go back to my original problem here, 5.4 divided by 0.2, 27. Okay? So we're going to work with much nicer problems by trying to get rid of the decimal. And here's the idea. We want to try to get rid of the decimal only in that second piece. We can leave some decimals behind here. Okay? It would be okay to do it the other way, but it would end up being a lot more work on our part. So our goal is going to be to just turn the second one into a whole number. So here's what's going to end up happening. Move once, move twice, this becomes 63. Okay? That means I can do this here too. Move once, move twice. I have a space to fill in, so this one's going to be 1690. Okay? So again, we have to do a whole number problem. This was a decimal problem. This is a nice whole number problem. 63 goes into 1690. Okay? Well, 63 does not go into 1. 63 does not go into 16. 63, the first number is 169. So 63 into 169, it looks like I can go twice, right? Because if I try to go 3 times, I'd be 180 something. That's too big. Okay, so 2 times 3 is 6. 2 times 6 is 12. Okay, let's do some subtraction. 9 minus 6 is 3. Okay, 6 minus 2 is 4. Okay, and I end up with a remainder of 43. I'm going to bring down my 0. Okay, and so this one's going to be slightly more work. I forgot how many times does 63 go into 430? This is where our estimation skills come into play. Well, because 60 would go in probably 6 times, right, or 7 times, right? So we actually have to figure this out. So I'm going to come off this side. It's about 6 or 7. So I'm going to say 63. Let's do times 7. See if we can fit the larger one in. 7 times 3 is 21. Okay, 7 times 6 is 42 plus 2. 441. Nope, that's too big, right? So that means I'm going to have to decrease this one and say let's only go in 6 times. Okay, so 6 times 3 is 18. Carry a 1. 6 times 6 is 36 plus 1 is 37. That keeps me below the 430, right? As close as I can get without going over. That's the goal. So let's do our subtraction again. Okay, I got to borrow here. Make that a 2. That's 10 minus 8, which is 2. Again, 2 minus 7 doesn't work, so I'm just going to get rid of that, make it a 3, make this a 12. 12 minus 7 is 52. Okay, so now I have 63. The remainder here is 52. I have to start moving into decimal territory now. I'm to the end of the number. There's going to be a decimal point here, which means a decimal point here, and that allows me to put a 0 on the end, which I can bring down. Okay, so I'm only going to go one more time. 9 goes into 63. I'm sorry. 63 to 520, I'm thinking about how high it can go. Well, 9 times 60 would be 54. That would be too big. So 9 times, let's try 8, right? So let's do 63 times 8. And again, I'm kind of just trying to get a good estimate here of how close I can get. 8 times 3 is 24, carry a 2. 8 times 6 is 48, plus 2 is 50. 504, right? So if I use an 8 here, I'm getting pretty close to 520, right? 8 times 63 we just did is 504, okay? And that looks like 520 minus 504 is going to be 16, right? So I'm not going to keep going because that's really not the point of this problem is to continue forever. We can go as many decimal points as is necessary, right? In this case, I could actually keep going at least 2 more decimal points. But the idea here, big idea here, is that we always want to divide by a whole number. Okay, I had in my original problem, if you forget, it's been a while because we had to go through all this tedious stuff down here. Our original problem was 16.9 divided by 0.63. Okay, and so we decided instead to do 1690 divided by 63. That's when we got into all this work. So the answer to our original problem, 16.9 divided by 0.63, is also about 26.8. Right, if we were to estimate 26.8 something, right, we didn't actually get all the way to the end, but about 26.8 is our answer. And usually on a quiz or a test or any kind of thing, they'd tell you how far in the decimal places to go. But in this case, we're going to stop at the 10th place and say 26.8. Okay, so big idea. The second number should always be a whole number. Don't divide by decimals because that's a little bit complicated. Okay, so I'm going to do just one more of these. Actually, I don't think I'm going to do these. This is the same idea, so I'm not going to do any more. The idea here in both of these cases, we'll just do the setup that I want to move this one over to the right and make it 4, which means I'm going to move this one over to the right and make it 189. Right, so we could do this one with the long division. Same thing here. This one I need to move over twice. Okay, which means this one I'm going to move over twice. Okay. And end up with 1120 divided by 137. Okay, and again, this is something we could do using long division. All right, so let's talk about the last little bit of dividing, and that is, again, our good friend tens. Tens are awesome when we're talking about decimals because the whole decimal system is based on multiples of 10. Here's the catch, though. When you divide, right, if you remember from the last video, or the last topic when we talked about multiplication, we said if you multiply by any multiple of 10, the decimal point goes to the right. Now we're dividing by a multiple of 10. The decimal point is going to go to the left by however many zeros that multiple has. So again, here's what we mean. Okay, this has 2 zeros. That means I'm going to move this 2 points to the right. I'm going to put a number right there and say 2.5439543, right? So whenever we're dividing by a multiple of 10, like 100 or 1,000 or 1,000,000 or 1,000,000,000, we don't have to worry about all of the tediousness that we had to deal with in these types of problems because the whole system is based around 10 and things always work out really nicely. Okay, so if I were to look at this number, 11,345.22, I see 1, 2, 3 zeros. That means I'm going to go to the left 1, 2, 3 zeros, and my number is going to become 11.34522. Okay, so I'm just going to talk about a couple of little things here, and then we will be finished. Here's the first thing. Okay, again, always check your answer to make sure it makes sense. If I'm dividing by 1,000, my number better be much smaller than I started with. So again, I'm not a big fan of rules ever. So instead of trying to memorize a rule, just look at your answer and say, does this make sense? I'm not sure whether I'm moving to the right or to the left. Well, if I were to move to the left, I'd end up with a number much larger than it used to be. And when we divide, that usually doesn't happen. It ends up being smaller, right? So 11 makes sense because we ended up with a number that was 11,000, and then we divided it into 1,000 pieces. 11 makes sense. Okay, so don't try to memorize a rule. Do I move to the left or to the right? Try to think about which way is going to make sense when we're using division. Well, in this case, moving it to the left creates smaller numbers. That makes sense. Okay, here's the last little bit. If you're ever using this rule, I'm going to do something like if I had like 1.27 divided by 1,000. Okay, and as you're moving to the left, you run out of numbers, right? So in this case, I have again 1, 2, 3 zeros. I move it to the left by 1, and I'm like, well, wait a second, I don't have anywhere else to go. Move twice more. Okay, I want the decimal point to be right there. Okay, so I did 1, 2, 3 jumps, and then I'm going to put zeros at the beginning. So this would be 0.00127. Okay, so it is possible that as you're moving that decimal point to the left or the right, you'll hit the end of the original number, and that's where the zeros come into play. So, okay, use multiples of 10. Okay, tens are awesome when we're multiplying and dividing. Okay, they will help your life immensely.